All right, so welcome to the video here for lesson number 9. I know in my accelerated class we already did the first part of this, and in my Regents class we kind of went through this kind of quickly. So I wanted to kind of just review some of the concepts here that we went over in class today, do the last couple questions in the notes, and then I'll do some homework problems with you here. So hopefully this makes sense. So essentially in class today we learned two things. We learned about amplitude and we learned about midline. Remember, the amplitude is a distance, so it's always going to wind up being a positive value. It's the distance from the midline to the maximum. So I know we put notes in this part here, but I want to just kind of look at it graphically for a second. So if I have a sine curve, the amplitude winds up being the distance here. The amplitude is the same distance here. So it's the distance from the middle of the graph to either the maximum or the minimum. Now this makes sense for both sine curves and cosine curves, right? So the example I gave you here was a sine curve. If I was to draw a cosine curve, the same thing applies. The cosine curve would come down and back up and look like this. The amplitude is still the distance from the middle of the graph to the top of the graph. Okay. The other parameter that we looked at was midline, which again we can look at graphically here. So the midline is where the middle of the graph is. So for example, if I have a sine curve that looks like this, the midline winds up being that line that cuts the graph in half. Notice the amplitude is still from the top to the middle, and then the midline winds up being right in the middle. So these two parameters actually kind of are linked together. Because to find the midline, you need to know the amplitude, or if you know the amplitude, you can find the midline. It's kind of like you need to know one or the other. Okay. Some of the questions that they could ask about this is just identify what the midline is or what the amplitude is, or like we did at the end of class, we could go through and actually sketch some of these. So let's take a look at the examples at the end of class. And again, I know in some of my classes I did these, some of I didn't. So if you got what we did here and you want to just fast forward right through to the homework questions, that's fine. Or if you just want to rewatch it again or learn it for the first time, that works too. So here is an example. It says determine the amplitude of a function where g of x has a value of 4 sine of x. This number here, that's the amplitude. So now I know the amplitude is 4. Since there's nothing added to the sine of x, I know the midline is going to be 0. Now to find the maximum and the minimum, the maximum is going to be the number from the midline to the added to the amplitude. So for example, in this case, I'm starting at 0 and I'm going up 4 boxes. So the maximum is going to be 4 up. The minimum is going to start at the midline and instead of going up 4, go down 4. So that would be at negative 4. So that tells me that this sine function is going to oscillate between negative 4 and positive 4 forever. So it's going to go from negative 4 to positive 4, back down to negative 4 forever. So the range of this function is never going to be outside of the numbers negative 4 to positive 4. I'm using brackets because it's inclusive. We're actually including those values in the range. Now to sketch one cycle of this function, we're first going to start by making an x and y axis. I know the maximum is 4, so I'm going to go up to 4. The minimum is negative 4, so I'm going to go down to negative 4. Now, here's where things kind of get a little bit different depending if you're somebody that truly understands what's going on or you're kind of just getting it. The x values here can be in degrees or radians. It actually doesn't matter how you do it. A lot of times, however, they are going to ask you to do this in radians. I know in my Regents class today, we just did degrees to kind of wet your feet a little bit, and we'll talk more about radians next week. So if you were putting this out, you're going to separate this into 4 parts, one for 90 degrees, one for 180, 270, etc. 90 degrees is pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. So in class for the region students, I put 90 degrees, 180, 270, 360. That is totally fine, right? But we really want to start to be able to use radians here. So let's look at what this graph is going to look like. So I know the generic sine curve is going to start at 0, go up, back down, and end back at 0. So it's going to use that same pattern, but this time we have a stretch, we have an amplitude. So instead of going up to 1, I'm actually going to go up to 4. Then after the maximum comes back down to the minimum, then it goes back down completely and back up to 0. There's one cycle of the sine curve. A couple of you asked me in class, how would this be different if it was a cosine curve? And I didn't have time to answer that question in class, so let me answer it now. So if this was a cosine curve, I would start at the amplitude and come down and then back up. So what I just graphed in blue would be the value of cosine of 4x. I'll do that for number 2 as well, so you could just start to see the difference here a little bit. So let's take a look at number 2. Number 2 says the sine of x plus 5. So in this case, this is the midline. There's a 1 in front of sine, so I know the amplitude is 1, and the midline is 5. Now, if I know the amplitude and midline, I should be able to figure out the max and min. Max is the midline plus the amplitude, so that's 6. The minimum is the amplitude, and then go down 1, so that would be at 4. Meaning the range of this function is from 4 to 6. So keep that in mind before you go through and sketch this. So when I want to sketch this, I know that this whole graph is going to be completely above the x-axis. So I don't want to make it so that I see a bunch of points below the x-axis here. So I know that I'm going up to a maximum of 6, a minimum of 4, and 5 is going to be right in the middle. Just like before, I'm going to separate this into 4 parts. One for pi over 2, pi, 3 pi over 2, and 2 pi. So if we go through and start to graph this, since it's a sine curve, I want to know where this midline is. So I'm going to draw in the midline. I'll start by going at the midline, because sine curves always start at the midline. And then sine curves start by going up to the maximum, back down to the midline, down to the minimum, and then back up to the midline. It's going to be the same curve, just like translated up. Now again, to answer that question from before, what happens if this was not sine? What if it was cosine of x plus 5? Well, cosine curves start at the amplitude. Then at 90 degrees, they go to the midline. At 180 degrees, they're at the minimum. 270, they're at the midline again. And at 360, they've completed a full rotation. So your cosine curve would be what would be in blue. So if that was a cosine curve, that's what we would see. All right, let's take a look at the last one in the notes. So the last one in the notes gives us kind of every parameter that we possibly can have. So it tells us that we have this amplitude of 2. Notice I'm not putting negative 2 there because that negative is not part of the amplitude. It's just a reflection. I know the midline is 3. Well, if that's the case, then that means the maximum's 5, because if I start at 3 and go up 2, I'm at 5. The minimum value is 1, because if I start at 3 and go down 2, I'm at 1. Meaning the range is from 1 to 5. So again, just like example 2, I don't really need anything below the x-axis. I know I'm going to go from 1 to 5, and I know 3 is going to be right in the middle. Still going to go out our 90, 180, 270, and 360. And the first thing I want to sketch is always the midline, because that's kind of our point of reference or line of reference. So because this is cosine, I know cosine curves are going to start at the midline. I'm sorry, they're going to start at the maximum or the minimum. Because of the negative, I want to start at the minimum. So the first point here is going to be 1, 0. Because this is going to be a cosine curve that's upside down, right? Normally a cosine curve looks something like this. Well, I want an upside down version, so it's going to look like this. At 90, I'm going to go back to the midline. At 180, I'm going to go to the maximum. At 270, I'm going to go back to the midline. And at 360, I'm going to go back to the minimum. That's my cosine curve for this function f of x. Say, for example, this was not cosine. Say this was -2 sine of x plus 3. Well, since it's sine, I start at the midline. Since it's negative, I'm going to go upside down. So I'm going to go down first, back to the midline, back up to the maximum, and end back at the midline. So that blue curve would be if this was a sine curve instead of a cosine curve. At this point, I'm going to tell you to pause the video so that you could try your homework assignment. So I want you to try the homework before you start to watch the video, because that makes the most sense. And then you can watch the rest of the video to see what the homework answers look like. All right, so welcome back. So I'm hoping that you had a chance to try the homework here. Notice it's asking you to sketch 5 different graphs on the same set of axes, which can be a little bit confusing. So if you used what it said to do here is to use 3 or 4 or 5 different colors, it actually makes a little bit more sense. So let's start by graphing f of x. Notice these are all going to be sine curves, just to kind of get us into the way of doing this. So for the first sine curve, it says the amplitude is 2. So the x-intercepts are going to stay the same. At pi over 2, I'm going to go up to 2. And at 3 pi over 2, I'm going to go down to -2. And I'm going to keep following that pattern past 2 pi. So I'll see the curve actually kind of looks similar. And I'll use some color here just to show which one is which. The sketch doesn't have to be perfect. I'm really just seeing that you understand the range and all of that good stuff. The next one says -8. So since it's negative, I know it's going to be upside down. And I know it's going to go from -8 all the way back to +8. But it's still going to start at 0, 0. But at pi over 2, instead of going up to +8, I'm going to go down to -8. So I'm going to go back to 0. And instead of going down to -8, I'm going to go up to +8. And I'll end up here at +8. So my curve is going to look something like this. Couple key points about graphing these. Make sure that they are curved and not pointed. Right? These are hills and valleys. Think about it that way. It makes it a little bit easier to understand. The next one says to graph the sine of x plus 3. Well, that's going to have a midline. Midline is going to tell us that we're shifting up. So that means we're going to start at 3, 0, or 0, 3, sorry. And since it's sine, it's just going to go up 1, down 1. So it's going to go up to 1, back down to the midline. So that first hill is going to be really shallow. And it's going to go down to 2. And then back up to the midline. And we're going to keep following this pattern on and on and on for the rest of this graph. Whoops, that was too low. Not gonna lie, I know these didn't photocopy well, so just kind of bear with us here. So it goes up, and then down. Like that. The second half looks like garbage. Let me fix that. So we go to here. Then it goes up to 1. That looks better. Back down to here. And then back down to here. That looks better. All right, so the next one says to do the same thing, but it's going to go down 5 instead of up 3. So we'll do that one in pink. All right. So if we go down to -5, it's still going to start at the midline. Since it's still got a positive number in front, it's going to go up 1. It's then going to go back down to the midline. Then it's going to go down 1 from the midline, so we'd be at -6. And it's going to go back up to the midline. And then back up to -4. Back down to the midline. And then end at -6. And the last one is combining both ideas. So we have an amplitude and a midline. So this one's going to start at 2. At 90 degrees, it's going to go up by 3. So 1, 2, 3 would be at 5. It's going to go back down to the midline, 2. Then at 270 degrees, it's going to go down by 3. So if I start at 2 and go down by 3, it'd be at -1. Then if I go back up to the midline at 270 degrees, it would be somewhere like here. Then from there, I want to go up by 3, so I'd be at 5 again. Then I go back to my midline again. And then ending at -1 again. So each one of those curves is a sine curve, just with some kind of a stretch or a vertical shift. The next part of this problem asks us to identify the midline and determine the range for each function. So for function in part A, and we'll do this by part. So part A, the midline. So if I look at the graph for A, it's 2 sine of x, so the midline is 0. The range, well, if I start at 0 and go down by 2, I'm at -2. If I go up by 2, I'm at +2. I know I'm going down and up by 2 because of the amplitude of 2. Part B, the midline is also 0. And the range, since the amplitude was 8, is -8 to +8. For part C, this one had a midline that wasn't 0. So the midline for part C was 3. Since the amplitude is 1, I know it's 1 because there's nothing written in front of sine. The range is going to go down 1, so 2, and up 1 from 3, so that's 4. And that's where my graph will be completely enclosed between. It's going to oscillate between those two values. For part D, the midline was -5. If the midline's -5 and the amplitude is 1, the range is going to go down 1 from -5, so that's -6, up 1 from -5, so that's -4. Make sure you write them in the correct order, right? Least to greatest. And the last one, part E, which had both a range and, a amplitude and a midline that we had to worry about. So the last one here had a midline of 2. And since the amplitude's 3, I know the range can be found by going down 3, so -1, and up 3 to +5. So hopefully this video helped. I know that this can be a little bit confusing, but it will get better as we practice this more. We're going to spend a lot of time doing this next week, right? So if you have questions, please come and see me after school. I'll be after school at least one day next week, if not two, all right? And I know it's a 3-day weekend. Hopefully you're watching this long 20-minute video, all right? Best of luck and enjoy your 3 days off.